Hello, everyone. I'm really glad to be here again. I want to talk to you mostly about the future of AI search infrastructure. I think it's a very underappreciated part of the infrastructure stack. Ultimately, if you want your LLM, your chatbot, your agents not to produce sort of hallucinated slop, then you got to give it some useful stuff into its prompt. Where does that prompt really get its information from for both company internal use cases and web use cases? From a search backend. And so you can really tell how accurate and how good and up-to-date an LLM is based on the search infrastructure that sits underneath it. And more people are realizing this, but it's still a surprise to many. But before we jump into sort of that detail, I want to start with a couple of fun predictions for the year. A lot of people enjoy these. There are too many, so I'll jump into just a couple. Many folks are worried about jobs, right? And there's some various memes going on of people saying, oh, in 2019, I became an ML engineer, and then I became a prompt engineer, and now I'm like an agent manager, and next year I'll be unemployed. And so I don't think that is true. At the same time, when work changes, a lot of people say, well, what will the new jobs be? And for the most part, it's actually hard for us to know. Just like, imagine 150 years ago, 90% of people worked in agriculture. If you told them like, hey, 90% of those jobs are gonna be gone, but you'll still all have a job, they're like, well, what would it be? And 0 people predicted that you're gonna have a Facebook media marketing manager role 150 years ago. That is how clueless we are right now about what kinds of jobs there will be in 150 years from now. But what I think we can predict is that there will be this new kind of job called a reward engineer, which is essentially like a more sophisticated and much broader prompt engineer for agents that can actually take actions, right? And I'll give you a simple example. You work in like customer service, and you want to basically, tell your new super intelligent agent that we're gonna get in the next 2 to 3 years at the latest, and distribute it broadly. You tell it like a reward, like give my customer satisfaction score after phone calls up to be 4.9 out of 5. To which a very intelligent AI agent will say, okay, easy, and then just spawn like 1 million bots that spam your call center and then give a 5 out of 5 rating at the end. You're like, oh, that wasn't good. Just like, it has to be with real people. The reward engineer will then tell the agent, which the agent will say, easy. Week later, you lost hundreds of thousands of dollars because you just gave a $1,000 gift certificate for everyone who called, and that got that 5 out of 5 rating. You're like, not like that. And so you keep having to actually really well define how to what success looks like, how to actually be good at your job, and then you need to manage those kinds of expectations. And so that is going to be one example of what is called the lump of labor fallacy being proven again and again. That basically work isn't zero sum, and we will all find something. But at the same time, it will be a transition, and if you kind of made up your mind about a certain tool, a certain like automation of some kind, like you shouldn't, because every month or 2 months the technology has improved, things are moving very quickly, and you should give it another try, especially right now in coding. It's more obvious than when I said this like a year ago. I think now if you're just halfway active on Twitter X, you'll see so much excitement, and hopefully that will push you all to use these tools in your day-to-day research work and engineering work. We'll talk a lot more about the search infrastructure throughout this talk, but if you want to do something not just that is accurate and up-to-date, but also is more unique, that often will also come through the search stack of your LLM. And so what we're seeing a lot of success with now is essentially offering vertical indices to specific companies and specific industries like legal, healthcare, news, hospitality, and so on. That is how you get your agent to do much more unique things. I'll just mention that at the very end again, but I think we're going to be we're still just at the start of this AI moment. A lot of people wonder if there's a bubble, and I actually do think there's a bit of a bubble. I think there are some neo labs of just very junior people, or like folks that haven't really had an amazing track record of building incredible things in AI, and they're still able to raise insane amounts. And so not every company will succeed in this time right now, but I think it's also fairly clear that in 20 years from now, just like 20 years ago with the dot-com bubble, the most valuable companies, the multi-trillion-dollar companies, have started throughout these years. And just like with the dot-com bubble, where maybe pets.com was ahead of its time, right? But now people mostly order their pet food online, right? And so it was the right idea at the wrong too early. And I often say back when I was a researcher, if you're a researcher and you're ahead of your time, you're called a visionary. If you're a startup founder and you're ahead of your time, your company is just dead and no one cares, right? And so that is also true for this time right now. So let's think a little bit about how we are not one of those companies that are ahead of their time and actually build stuff that people want and can reliably use in their work environment. It's still shocking to me how many companies are failing massively in their AI deployments. And we see these many places in the government, sometimes military, in the legal system, and in much more mundane other environments. And very often it's related to not having this accurate search backend. And to make matters worse, the two previously only good search indices of Google and Bing actually are shutting down their APIs so that you use their entire AI stack rather than being able to build your own AI stack and use this as part of your overall stack. And so we actually at U.com had to build our own web index, which is quite expensive. It's also nice because it's moat. It's not, no one's going to vibe code and web index over the weekend, which will actually happen to a lot of other SaaS companies. I just came back from Davos, and one very senior CEO of a very, very large tech company said that basically they're going to try to get rid of 75% of all their SaaS subscriptions within 1 year. So, that's a pretty big statement. You can basically now, if you pay maybe $50K for a piece of software, there's a good chance an engineer inside the organization could vibe code that piece of software in a week or two. And so basically, you want to work on either some of the infrastructure, or you want to use the fact that you can very quickly build something on top of that new AI infrastructure stack. And so it's made harder because there aren't as many good stacks. And even just like the last few days, Google further restricted an already very restricted search API, which is good for us, but not many people know about us, as many people who should know about us. So some of them are left dry and don't have as much access to accurate information. So how are we thinking about AI search different to traditional search? In some sense, how should you build things differently if you want to build a Google for LLMs rather than a Google for people? I think a big difference is in how many results a human web index will return to you, right? You see these numbers of all these different pages. Now, of course, most things are dead, and if you want to hide something, you hide it on the second page of Google in the world, right? But at the same time, there's also a lot of repetition inside Google results, whereas for an AI, you really only need to show a fact once and then say, this fact is cited in multiple different places on the web, right? And so you can actually, instead of building it for browsing and for opening multiple tabs and building confidence in your answers as a human, you can have done that, you can do that already for the AI and then just give it, here are the main facts based on a certain query. And then, of course, there are all these sub-requirements, and this is something that as you go into enterprise, you kind of learn, that you want to have a very simple experience for your product that just looks like you can build it and use the tool within 10 minutes or something. But then if you want to get to larger and larger customers, you have to have all these bells and whistles. I'm always mind blown when I go, don't do it fortunately too often, but once in a while I go into the Zoom settings on the web. They're not even in the app, they're on the web. There are like literally hundreds of pages of Zoom settings of like, if someone joins late and then they have the thing and then they assign this to someone else who should have the permission to do this and that. Like it's crazy. And so this customizability is something that we're seeing in AI search too. Some people want to include certain sites, crawl them very frequently. Some want to exclude certain sites, exclude entire domains. And some folks want to use AI search for training, so then you need to be able to have like a massive lump of search results that you give very quickly. Others want to have, but then the actual latency doesn't matter too much as long as they can get big lumps of results quickly. Others have it running live in their either search engine or their consumer LLMs, and then the requirement on latency is insanely high. So there's a lot of different ways to basically look at this Pareto optimal frontier of accuracy and speed, and you need, like, different customers will have different requirements on that. Real time is something that's big, and we basically provide now the ability to sort of live crawl other pages to, or just have it already pre-cached at certain frequencies and things like that. So a lot of really interesting subtleties as we're building out this Google for LLMs. Now, just a little bit self-congratulatory slide, thanks to my marketing team, but it does make sense to talk about this. We're now doing this over 1 billion times a month, and it's actually a really interesting sort of insight here on how humanity is getting knowledge, right? Like over 1 billion times a month, someone reads an answer, and while they mostly think, oh, this LLM is so great, that LLM mostly summarized what it got from the search engine, which we provide. And so it's actually really meaningful to give people knowledge through an LLM. So it's one step removed, and for us, it's more of a B2B to C kind of setting, but it's really powerful and very meaningful. We have companies like OpenAI, Alibaba, DuckDuckGo, The Telegraph, Databricks, Harvey, AI for Legal, Windsurf, AI for Coding, Amazon. They're all customers of these search APIs and many more. Huge penetration in like Fortune 500s, which is interesting too. And so maybe, outside of just the speed and accuracy trade-off, one big part of the accuracy actually comes from having richer snippets. In Google SERP APIs, you might get like a very short snippet that you'd see on Google, but LLMs could read that and a whole lot more very quickly, so you want to basically provide much, much longer snippets up to the entire page. It becomes one of those many settings I was referring to earlier. Now, we mostly I've been mostly talking about this general web index, but it turns out there are these vertical indices too, where when you work, for instance, with a legal company, and that legal company has crazy requirements for very specific niche, like 1977 rules from Portugal that even Google hasn't indexed, you want to then be able to bring those results to them through these custom indices. And if you're working in a specific industry, happy to talk to you about what your industry might need and how we can help with that. This is kind of part of that Pareto optimal frontier I mentioned. Something we often look at is just the latency. So it's kind of a little bit weird. Technically, latency should be from right to left, but here I just wanted to have the faster thing that's better is up and to the right. It's again sort of as an engineer, it kind of pains me to look at it, but marketing is like, it's got to be up and to the right, Richard, And so really exciting to see here that when it comes to speed versus accuracy, this is actually the best potential API for your LLMs. This is one such example. If you actually go in DuckDuckGo, amazing privacy-preserving search engine, and you look at the search results, especially when it comes to news, you see here a little source of view.com. And the reason why this is a particularly cool example is that the requirements are kind of insane, right? This consumer search has to be super duper fast, so the latency requirements are like a few hundred milliseconds, like so much so that we had to set up new data centers in different geos so that remaining last 10 to 20 seconds of ping time gets reduced. You have to have a broad coverage of all the news. It has to be not just fast in terms of retrieval, but also fast in terms of updating the entire index, which is also non-trivial. Something happens every 5 minutes. No one can train their LLM every 5 minutes. Something happens in the world. And then the click-through rate and the ranking has to be really good, even though almost by definition you can't collect that much data on what gets clicks or doesn't, because it's new stuff that happens every couple of minutes. So that, to me, is a really beautiful proof, and proof sort of to our technology is quite ahead of a lot of other folks. This one is another really cool one. If you go to OpenAI's GPT OSS, we're actually now the default also, and they're nicely sort of implementing the whole thing in their browser and tool use. And you can see here, this is the default. So if you just use GPT OSS from OpenAI and you work through the GitHub to get it live, you'll end up using the u.com APIs for your LLM. Similar in Databricks makes it very easy now to use these tools. Now, benchmarks are really powerful. I'm a big believer of benchmarks, but it's also clear that for a lot of people, that's just marketing. And I can't quite, take my old professor hat off and cringe when I see a lot of benchmarks out there that aren't verifiable, that aren't done by third parties, and are just basically marketing materials. So whenever we have other folks kind of write research papers about answer engines and accuracies and how many answers are one-sided or overconfident or don't have relevant statements and things like that, or have uncited sources, I feel like it's not very reliable. And so we open source almost all our benchmarks so that engineers can actually run them and say, oh yeah, this isn't just marketing, blah, blah. These are real, and I encourage you all to always do that. In fact, I feel like for most companies, you can see how sophisticated they are in AI based on how sophisticated their benchmark and eval frameworks are, right? And in AI, you should really stop making any purchasing decisions without having a proper benchmark. And the other thing that we love about benchmarks is that every customer that can run them ends up becoming our customer. We win the deal because we have the best AI search infrastructure out there. But it takes a long time, and it's actually honestly surprising. This is a paper published by Salesforce Research like just last year. And you can see here sort of how many reds and greens there are across all these different offerings. And you would think like there's no way a small startup like u.com could beat the Gemini or Copilot or OpenAI GPT-5 and so on. But it is actually possible. So like if you focus on like one particular vertical, one particular use case, you can actually outperform some of these really large companies. Now, this is almost a philosophical point that I want to make here, but that I think it will become more and more important in the next few years. And that is that most of the AI that we've built is stuck below or just around what I call Enthropic Bounds. It's no dig to the company Enthropic, but basically it's in the sense of they're human-made, right? Like when you think about how we evaluate AI, it's based on like human IQ tests, right? Well, that is humans thinking about questions and then defining what the right answer is. And then AI can get at most 100% of the answers right. So how would you ever, in that setting, notice that the AI became superhuman? It cannot get above superhuman because we're only evaluating it up until human intelligence and having 100% on our IQ tests kind of right. And so I think as we're moving into this new world of superintelligence, we need to think about allowing the AI to set some of its own goals, to create its own benchmarks, and then decide how to really optimize towards those. And I think that will be a big shift. No AI has yet created its own useful benchmark. We're not letting it, we're not asking it to, right? We're defining the goals, and then the AI will sort of robotically follow and optimize towards those goals. but that will mean that, whatever the human baseline is, all the AI will usually slow down around that space. I just finished a book a few months ago called The Eureka Machine on AI for Science, and in the last chapter I talk about what would be ways that we can sort of unbound AI from these human set goals, and what would be true upper bounds for intelligence. And a lot of times those upper bounds end up being in physics, how much storage could you store in a certain amount of volume and mass? The visual intelligence, I'll just give you one sense of what I mean by these entropic bounds, right? We often think about computer vision in terms of very narrow band of the electromagnetic frequency spectrum that we personally as humans can see, right? But you can go all the way down to gamma rays and down to observing molecules as they wobble around, all the way to different kinds of frequencies of gravitational waves. It's sort of one of the largest potential waves you could observe. We could never observe it, right? But our scientific instruments could, and an AI could. And so an AI doesn't have to have just stereo vision. You can have millions of cameras coming into one place. It doesn't have to be restricted to the electromagnetic frequency spectrum that we can observe. It could go and observe things from in all kinds of scales, down to atoms, all the way to gravitational waves. And then there's sort of bounds on how far away could all these different sensors be to still be able to communicate this given the speed of light. And so those are kind of the bounds that AI could get to. And that also should inspire you, because you can see how far away, we're literally astronomically far away from some of those bounds of any kind of intelligent entity in the universe. So anyway, short digression on entropic bounds is kind of fun to think about. Not most relevant for engineering right now, but I think hopefully inspiring to see that we are literally just in the very beginning of what AI can do and what we can start with. Maybe I'll end on this note here, which is, I think a lot of times when we build AI, we basically take human tools and infrastructure built for humans, and we kind of say, all right, now maybe AI can actually use this tool also that was built for humans, right? We've done this with GPUs that were initially built to play games, and really good at matrix multiplications. Neural nets great for need a lot of matrix multiplication, so that is awesome. I still remember actually in 2010 or 11, I was the first NLP researcher at Stanford buying GPUs, and NVIDIA was like, why are you talking to us? We don't want to talk to you. We're focused on gaming. It was very, very cool how much that changed. Then now we build GPUs that don't have graphics out, right? They're just custom built for AI. And we actually can see that exact same transition for a lot of other infrastructure we've built. Web browsers, right? Web browsers were built for humans. Now AI can do things through this projection of the world onto the web. We're going to see browsers built for AI. And in the case of U.com, what we're focused on is, we've built Google. It's really useful for AI too, but now we can actually build a search engine just for AI, inspired by what used to look like, what search engines used to look like for people, but really being quite different. And so I think as we sort of transition all these different levels of infrastructure to this new AI world, we're going to think about what is the next level. And my personal journey to this next level came a little bit from looking at the transition of moving from manual systems to learned systems. So we moved from manual feature engineering at the beginning of my PhD in natural language processing to word vectors and neural nets. Then everyone was at some point convinced, yes, natural language processing should be done with neural nets. But then everyone has started to do architecture engineering. It's like, okay, yes, it's a neural net, but I'm a sentiment analysis researcher, so my neural net looks like that, and this other neural net for translation looks like this, and the summarization neural net looks like that, and everyone was doing architecture engineering. And so then I published these two papers called Ask Me Anything and DecaNLP, where we said, no, we can just have one model, and you just prompt it with a question, and one unified model can answer any and all kind of questions for you. And that was one of the ideas that then led to ChatGPT, and they nicely cited it. But now we're all stuck in sort of manual context engineering and manual prompt engineering. And I think the next level will be, and maybe the last level that we'll need in AI, period, is to allow the AI to do its own research on itself, right? AI is code, and AI can code. So you can close that loop really well. I think we can have a much higher slope than anything else that we've seen so far. So those are some things I'm really excited about too. So thanks a bunch for your attention.
Thank you, Richard, for the wonderful sharing. I'm actually a student from UC Berkeley. Hopefully, hope that doesn't mind. So I really like your talking on like how astonishing you.com do on these like agent side of searching, something like that. But I'm also curious, like what would be the game like on the other side of the table? Because like in the past, people like designers, developers, they optimize the website for letting humans like better use it, like easier to find or something like that. But nowadays, like especially with the tool use capability improve, do you think there's also like a future for these websites to optimize towards the path where they let the agent to easier to like retrieve, manipulate and do things on it? Is there like a universal rewarding part where like every website is optimized towards that path for the like agent future? Thank you.
I love that question. I think it's exactly right. You will have to do marketing to LLMs in the future, right? And people did SEO. The truth is actually when a lot of people think about chat engine optimization, because chat engines mostly say what they hear from the search engine infrastructure underneath it, it's actually surprisingly similar still. But I think that will change over the next few quarters and years. And more you have to think about how to write it such that an LLM in its trained data will like what you said and be more likely to include that then as a reference and then have also a link to what you say, because what you said is somewhat unique compared to what else is on the web. So I think this is a whole new job. Maybe I should actually add that as another job category of just like LLM marketer. It's like you're marketing to LLMs to talk about what you have to say on the web. Yeah.
Hey, Richard, thanks for a lovely talk. Quick question. Do you have any thoughts on like how the ecosystem of languages are going to change? For example, primarily for like 4.5 decades, we have been writing languages mainly for humans, from low-level languages to high-level. How do you think, like, because we know as a matter of fact, a lot of code is already being written by agents, though being prompted by humans. So the need for humans to understand the syntactical nuances of the language is, I imagine, going to go down. So what do you think, like, where will the languages and compiler and representation and IR form of languages gonna go in future? Or
yeah,
to be honest, I'm trying to ask, how should we align for it?
Yeah, I think there's sort of a very pragmatic thing right now, which is you should actually write still clean functions with good documentation and so on. And it's even more important because then the AI can also use it and automate a lot more inside your code base. And then there's sort of a more philosophical, like longer term view here, which is computer science in many ways is this incredible science that of abstraction. You know, we get to higher and higher levels of abstraction. We started with like the most basic bits and shuffling and moving bits around, and then assembler, and then like C++, and then Java, and now to a large degree Python. And I do think English is, like, it sounds a bit like a trope, but like English is becoming like a new programming language. And of course, it's helpful to understand all these abstractions below at least a little bit. Like if you say, make this like sorting algorithm faster, and you have no idea about algorithmic complexity theory, you can prompt it for years. It will never give you something that's faster than the theoretically best search or sorting algorithm that could work. And if you know the theory, that will help you prompt better. At the same time, we've gotten really good at building tools so that more and more of these abstraction layers can be irrelevant. Like you really don't need to understand like how things actually happen in a chip and actual zeros are moved in silicon and so on anymore. And I think we'll see that ability to create more and more with less and less knowledge of the stack, thanks to that abstraction. And so I do think there will be some co-adaptation in our language too as we prompt, similar to how people talk differently when they wanted to be really well transcribed, right? You speak a little more clearly so the AI doesn't make a weird mistake for you. I think similarly, we will adapt a little bit to an English language that is very good for prompting. And yeah, I'm all for it. I think it's going to be a really exciting time. And ultimately, the only constraint you're going to have is your agency and your intelligence of knowing what's possible and what isn't yet quite possible. And then in this really weird way, I think a big change that I can see is who owns the work that you do while you're doing it. Recently I talked to another VC, and mostly talking to VCs is not that interesting, but he brought up an interesting point, which is imagine if you do work, you have your own AI. I have my Richard AI, and that Richard AI follows me around everywhere I go, such that when I've done enough of something, my AI can just do it for me. Imagine how different that is than every place you go, and that place where you work is owning the AI, right? Now, the problem is, of course, if you do work and people pay you for it, they don't want you to learn a separate AI, right? So right now, I think legally that cannot happen in most places unless you're a freelancer, right? And I think that extreme point is kind of one potential future where the more you are your own boss and the more you care just about the outputs of your work, the more you're going to love AI, and the more you're paid by the hour for someone else, the less you're going to love AI. So I encourage you all to think about becoming owners, having at least some equity and so on of where you work, so that you can be at least to some degree owners. And that was a long-winded answer to the language that we'll see change. Thank you. Thank you.
Thank you, Richard.
Thank you.